The oceans have absorbed more than 90% of the global warming created by humans since the 1970s. Had that heat gone into the atmosphere, global average temperatures would have jumped by almost 56 degrees Celsius. But as vast as the seas are, there is a limit to how much heat they can absorb, and they are beginning to reach it. First way are that higher temperatures are bad for fish, and for us. Warmer waters cause coral bleaching, which in turn impacts coral reef ecosystems that are home to a dizzying array of marine biodiversity, and provide crucial sources of food for people. Warmer waters threaten to cause mass migration of marine species in search of the right conditions for feeding and spawning. For example, Conservation International research revealed that ocean warming is altering the habitats of tuna, causing them to move significantly to the east of the Pacific Islands. Change in water temperatures can directly affect the development and growth of most fish and cephalopods such as octopus and squid. Second way is polar ice melting. Both Arctic and Antarctica ice sheets are shrinking underwater, as submerged ice is rapidly melting, according to recent studies. The production of algae, the foundation of the Arctic food web, depends on the presence of sea ice. As sea ice diminishes, algae does too, causing a ripple effect on species from Arctic cod to seals, whales, and polar bears. Dwindling sea ice results in the loss of vital habitat for seals, walruses, penguins, whales, and other megafauna. Third way is rising sea levels represent a slow, unstoppable threat. Unprecedented rise of sea levels that has the potential to displace more than 680 million people living across low-lying coastal communities, according to a 2019 UN report. Several major coastal cities could be almost entirely underwater due to sea level rise by the middle of the century, including Ho Chi Minh City, Vietnam, Shanghai, China, and Mumbai, India. The survival of coral reefs, mangroves, seagrasses, and other critical habitat-forming species hinges on their ability to move into shallower waters. Critical coastal habitats, for instance, sea turtle nesting beaches, are lost as the sea level rises. Fourth way is warming oceans alter currents. Climate change affects ocean temperatures as well as wind patterns. Taken together, these can alter oceanic currents. As mentioned earlier, many marine species' migratory patterns can change as the currents they follow are altered. The impacts of changes in ocean currents on humanity could be severe, as currents play a major role in maintaining Earth's climate. Changing these currents will have major implications worldwide for the climate, including changes in rainfall, with more rain in some areas and much less in others. The fifth and last one is climate change is affecting the chemistry of seawater. The same burning of fossil fuels that increases greenhouse gas levels in the atmosphere is also altering the chemical composition of seawater by making it more acidic. The ocean absorbs 30% of the carbon dioxide in the atmosphere, and when that carbon dissolves into the water forming carbonic acid. Acidification can dissolve the calcium carbonate shells of marine species and some microscopic plankton that are a foundation of the food web throughout the ocean. The disruption and destruction of coral reefs and shellfish will have profound effects on humanity, chiefly in the form of less food for people who rely on the ocean for it.